Good morning, students. In the last class, I explained about what? The effect of pressure and temperature on solids in liquids and gases in liquids. Okay. So in that solids and liquids, I told you, as the temperature increases, the solubility increases if it is an exothermic reaction. The density, the solubility decreases, sorry, not density. The solubility of the solid increases in liquids as the temperature increases if it is an endothermic reaction. Okay, I'll write once again solids in liquids. Why I am writing means solubility of solids in liquids. If the dynamic equilibrium is endothermic, then solubility increases with increasing temperature. If it is exothermic, okay, solubility decreases with increasing temperature. Okay, students. So this is what solubility of solids in liquids. This is effect of temperature. What is effect of pressure? Okay. So pressure don't have significant effect. Pressure don't have significant effect. Okay. So next one is gases in liquids. Okay. Solubility of gases in liquids. If the temperature increases, solubility decreases. Next, if pressure increases, solubility increases. Okay, this thing you have to remember. So in that, students, the pressure increases when the solubility increases, that I explained in the last class with diagram. Okay, so now based on the solubility of the gases in liquids, based on pressure, so many laws are there. So in that I am going to explain the different laws which shows the solubility of the gases in the liquids. Okay, so in that, students, English law is there. Okay, English law. Okay, so first law is what it says: the solubility of gases in liquid is directly proportional to partial pressure of gases or gas over the solution or gases on the surface of the solution. This is first one. Next, so this theory by Dalton contemporarily explained as the solubility of gas in liquid So your liquid is a solvent, this is a solute. The solubility of the solute with respect to solvent is taken as what? Mole fraction. So the solubility of gas is taken as what? Mole fraction. So then the statement is mole fraction of a gas in liquid is directly proportional to partial pressure of gas over the solution. Okay, students. So first one, it is the Henry's law who stated that the solubility of a gas in liquid is directly proportional to what? The partial pressure of the gas over the solution or above the surface of the liquid or the solution. Next, this Dalton contemporarily explained the mole fraction of a gas in the solution or in liquid especially is directly proportional to partial pressure of the gas over the solution. Okay, so the most commonly used Henry's law states that what? Combining these two students, we can easily say that the Henry's law, what is the statement of Henry's law means? This is Henry's law actual statement. Okay, how the Henry's law is modified means the partial pressure of gas. The partial pressure of gas in the solution. The partial pressure of gas in vapor phase. In vapor phase is directly proportional to mole fraction of the gas. Mole fraction of the gas in the solution. Mole fraction means that is represented by X in the solution. So students, if the has state Henry's law, then you have to state that the partial pressure of gas in a vapor phase is directly proportional to the mole fraction of the gas in the solution. Okay, this is the statement. Three statements are there. First is suggested that the solubility of gas in the liquid is directly proportional to a partial pressure because, as I told you, here one beaker is there, here solvent is there, that is liquid is there. Over that, gaseous molecules are there. Okay, so students, if pressure is more here, then solubility is more. As I told you, your piston is there. If you apply pressure on it, means the molecules come closer with each other and they dissolve in liquid. Okay, so what they said, the solubility of gas in liquid is directly proportional to partial pressure. Means here gas is there, they have some amount of pressure. So this is directly the solubility, how much they can dissolve in this liquid. This depends on what? This partial pressure. Means ಇಲ್ಲಿ ಒಂದು ಕಂಟೈನರ್ ಇರುತ್ತೆ, ಕಂಟೈನರ್ ಅಲ್ಲಿ ಒಂದು ಲಿಕ್ವಿಡ್ ಇದೆ, ಅದರ ಮೇಲ್ಗಡೆ ಗ್ಯಾಸ್ ಇದೆ ಅಂದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಓಪನ್ ಕಂಟೈನರ್ ಇದೆ. ಸೊ ಓಪನ್ ಕಂಟೈನರ್ ಅಲ್ಲಿ ಐ ವಿಲ್ ಶೋ ಯು. So listen, here bottle is there. Okay, so in this bottle, if you open the cap, we have some gas here. Correct? We have some gas here. In the open space, we have some gas, and this gas, air is there, has some amount of what? Pressure. Okay, so here liquid is the solvent, here it is the solute. Solute means there must be a gas. So here in this cap, the gaseous molecules as its own, what it is? Pressure. Okay, they have their own pressure. If the pressure is high, ಓಕೆ ಗ್ಯಾಸಸ್ ಇದೆಲ್ಲ ಅದಕ್ಕೆ ತನ್ನದೇ ಆದಂತ ಒಂದು ಪ್ರೆಷರ್ ಇರುತ್ತೆ. ಆ ಪ್ರೆಷರ್ ಲಿಕ್ವಿಡ್ ಅಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಆದ್ರೆ ಏನಾಗುತ್ತೆ, ನಾವು ಇದಕ್ಕೆ ಎಷ್ಟು ಜಾಸ್ತಿ ಪ್ರೆಷರ್ ನ ಅಪ್ಲೈ ಮಾಡ್ತೀವೋ ಅಷ್ಟು ಜಾಸ್ತಿ ಅದು ಕಂಪ್ರೆಸ್ ಆಗುತ್ತೆ. ಇಫ್ ದ ಕಂಪ್ರೆಸ್ಡ್ ಮೀನ್ಸ್ ದೇ ಈಸಿಲಿ ಡಿಸಾಲ್ವ್ಡ್ ಇನ್ liquids, that increases the solubility of gases in the liquid. So second one is the mole fraction of a gas in liquid is directly proportional to partial pressure. So before class I explained what is mole fraction, the number of moles of a solute to the number of moles of the complete solution, solute plus solvent. So we are having only solute is gas, solvent is a liquid. Okay, in that the mole fraction of the solute, the solubility nothing but how much gas is dissolved in the solution, that means mole fraction. So that mole fraction of the gas in the liquid is proportional to partial pressure. So comparing these two, the Henry's law is modified as the partial pressure of the gas in the vapor phase is directly proportional to mole fraction of the gas in the solution. Okay, so for this students we can write partial pressure is taken as P is directly proportional to a mole fraction. The mathematical expression of what? Henry's. So P is equal to remove this proportionality we will have KHX. Okay, so this KH means this is Henry's law constant. This is called as Henry's law constant. Okay, so this is mathematical equation for Henry's law. I hope you understood. The partial pressure of the gas P is directly proportional to mole fraction. To remove this proportionality we get some constant KH. That constant is called as what? Henry's law. Okay, so by knowing that students we can compare the mole fractions of two components or with any other, so you get a graph. I'll write graph here. It suggests Henry's law. Okay, so listen here, graph is there, that means partial pressure versus this is mole fraction, that is x-axis, this is partial pressure. So students, if we draw the increase in the mole fraction, if 0 is there, 0.01, 0.02, 0.03. If mole fraction increases, here partial pressure is directly proportional to what? X. Then partial pressure also increases from initially both are 0, then it is here, here, here. So we will get what? A straight line. We will get a straight line here. We will get a straight line. Okay, so this straight line gives what? This is listen, P by X is equal to KH. P is there, X is there, is equal to KH. Means the mole fraction is indirectly proportional to what? This KH is inversely proportional to mole fraction. Here mole fraction increases. If mole fraction increases, then Henry's law constant KH decreases. But if pressure increases, then KH increases. I hope you understood, students. So this is the graph which represents the mathematical equation P is equal to KHX. There we can ask the question, state Henry's law and give its mathematical expression or mathematical representation. This is the statement, that is the mathematical expression, and this is the graph how they varies. Okay, if the mole fraction increases, partial pressure increases, but this more entries are constant, decreases. Okay, so this is what I'm telling, the pressure of gases in liquids. So as I told you, so this pressure of gases in liquids, the dissolution of this gases in liquids has some extent of significance, some extent of uses. So what are the uses of that means? So this solubility of gases and liquids are very much used in what? Industries, especially cooling industries. So first one, this is very important. Uses of or significance of solubility of gases in liquids. So students, this one shows. So to increase the solubility, uses, not uses, illustrates, illustration for solubility of gases in liquids. Examples. To increase solubility of CO2 in cool drinks, the bottles are sealed with high pressure. So you know very well students, so many cool drinks are there, fruity is there, Fanta is there, so not fruity. Of course, not juice, I'm telling, just cool drinks like 7-Up is there, Mountain Dew is there, so many type of cool drinks are there. You like, you want to share means you just check that and you will just hold a thumb on the lid of that or mouth of that bottle means you will observe gas will evaporate and gas will liberate. If you shake that bottle, we will assume small bubbles. You will see small bubbles, air bubbles. Okay, so those are what the CO2 gas which is dissolved in the cool drinks. Understood? So to increase the solubility of CO2 in cool drinks, the bottles are sealed with pressure. If pressure is more, then when it is closed, students, there is no bubbles. If you open, the bubbles came out. I hope you understood in opening Coca-Cola, like 7-Up. You may observe that. Okay? If you shake the bottle, if you open, means that will get out of the bottle. Why? Because the pressure, when we open the lid, the pressure inside the bottle decreases. That pressure exerts, the CO2 gas came out of the bottle. ಅಂದ್ರೆ ಬಾಟಲ್ ನಾವು ಶೇಕ್ ಮಾಡಿ ಓಪನ್ ಮಾಡಿದಾಗ ಅಲ್ಲಿ ಬಬಲ್ಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಬಬಲ್ಸ್ ಯಾಕೆ ಫಾರ್ಮ್ ಆಗುತ್ತೆ? ಬಾಟಲ್ ಒಳಗಡೆ ಜಾಸ್ತಿ ಪ್ರೆಷರ್ ಇರುತ್ತೆ. ಸೊ ಆ ಪ್ರೆಷರ್ ನಾವು ಲಿಡ್ ಅನ್ನ ಓಪನ್ ಮಾಡಿದಾಗ ಓಪನ್ ಏರ್ ಅಲ್ಲಿ ಪ್ರೆಷರ್ ಕಂಪೇರ್ ಟು ಬಾಟಲ್ ಒಳಗಡೆ ಇರೋ ಪ್ರೆಷರ್ ಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಹೊರಗಡೆ ಇರೋ ಪ್ರೆಷರ್ ಕಡಿಮೆ ಇರುತ್ತೆ. So because of the spontaneous reaction ಏನಾಗುತ್ತೆ ಆ ಒಳಗಡೆ ಬಾಟಲ್ ಒಳಗಡೆ ಇರೋ pressure due to the presence of the pressure inside the bottle that pulls out the carbon dioxide outside. ಅಂದ್ರೆ carbon dioxide gas ನ ಹೊರಗಡೆ ಹಾಕಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡಿದಾಗ ಆ ಸೊಲ್ಯೂಷನ್ ನಮಗೆ ಹೊರಗಡೆ ಚೆಲ್ಲುತ್ತೆ. Okay, so this is first thing. Next, second one, scuba divers use cylinders with 15% helium, so not 15%, 11% helium, 56.2% nitrogen and 32.2% oxygen. Okay, so scuba divers use cylinders compressed with these three gases. Why? Because students, scuba divers means You know very well about the one who go deep in the sea. Okay, so scuba divers andre aquatic ಅಂದ್ರೆ deep in the sea, complete sea ಅಲ್ಲಿ ಕೆಳಗಡೆ ಹೋಗ್ಬಿಟ್ಟು ಏನು ರಿಸರ್ಚ್ ಅದೆಲ್ಲ ಮಾಡ್ತಾರಲ್ವಾ ಅವರನ್ನ ಸ್ಕ್ಯೂಬಾ ಡೈವರ್ಸ್ ಅಂತ ಕರೀತಾರೆ. Okay, scuba divers means one who work at under water deep. Okay, those are called as what? Scuba divers. So those scuba divers use cylinders. Okay, cylinders with what? Mixed with air, mixed with helium, nitrogen and oxygen. So what is the reason of that, student? What is the use of the cylinders? Okay, so first, when we go depth of the sea or depth of the water, the pressure increases. You know, in water so many gases are dissolved already. Okay, so when the scuba divers get inside the deep water, so the pressure increases. So when the pressure increases, so the dissolution of atmospheric gases in the blood increases. Okay, what happens when they get inside the deep water? Pressure increases. Okay, when pressure increases, solubility of atmospheric gas increases. Atmospheric gas nothing but N2. So many gases. Okay, atmospheric gases increases. What is that? Pressure increases means solubility increases. Then when they come towards the surface of the water, okay, when they come back, when they came out the surface of the water, the pressure keep on decreases. The pressure decreases means then once the pressure decreases, then what happens? Solubility also decreases. That means the dissolved gas releases. Okay, once the dissolved gas releases in the blood, what happens? So when they move towards surface of water, pressure decreases and also solubility decreases. When they move towards the surface of water, pressure decreases and also solubility decreases. So results in what? That the gases dissolved. The gases dissolved dissolved are released in blood. Okay, so this will, I will say students, if balloon is there, in that balloon if you add some pressure, it compresses. If you release the pressure, again it comes back to its original position. Okay, so listen. Understood that the scuba divers go deep into the sea, then the pressure increases means solubility increases. At that time, the atmospheric gases are dissolved in their blood. Okay. Next, when they move towards the surface of water, the pressure decreases. The pressure decreases means solubility also decreases. At that time, the dissolved gases in the blood, they releases. When they released, students, in the blood veins. Okay, the blood vessels, they form a bends. They form a bend which causes the movement of the hemoglobin in the veins tough. Okay, so due to the formation of the bends, they feel some amount of pain. Sometimes they may face the critical condition until death. Okay, it leads to the beds leads to what? Death also sometimes, and they are more painful. So to reduce these bends, they use the oxygen cylinders. So due to the addition of helium, so what it means? What is the reason of addition of helium means? It reduces the dissolution of nitrogen in our hemoglobin. Understood? So this is 1 mark, very important question. What is the role of addition of helium in the cylinders of scuba divers. Why the scuba divers use the cylinders with helium gas? Why? Because helium has the capacity to reduce the dissolution of atmospheric gas, especially hydrogen, in the blood cells. Okay, so to decrease that, helium in this cylinder is consists of this much of percentage of gases. So this is all about the scuba divers. So this is another one illustration how the gases are dissolved in liquids. Okay, so next one is due to the solubility of gases in liquid, that is increases with increasing pressure. Third one is higher altitude sickness, that is anorexia. So students, when we move deep inside the sea, the pressure increases, so the dissolution of gases increases. When we move upward, above the atmospheric layer, and when we move upside that mountain, okay. So the mountain climbers, they are also use cylinders, correct? Mountain climbers also use cylinders. Why? Because when we go up, okay, when we move, as I told you, inside the deep sea pressure is more, surface of the water pressure is less. In our environment, whatever we on the surface of the earth, pressure is less. When we move above the stratosphere, atmosphere, and there the pressure is less. When the pressure is less, I told you the solubility of gases is less. So pressure less means the solubility of gases in the hemoglobin level decreases. When the hemoglobin level, the oxygen dissolved in hemoglobin decreases, that results in giddiness. Giddiness means color. Okay, na? So that results in giddiness and higher altitude, that is called as higher altitude sickness, that is anorexia. So they never concentrate on what they are doing. They didn't think, because the not sufficient supply of oxygen is to all the organs of our body, means that results to death also. So if the pressure is less, then also problem. If pressure is more, then also problem. So we should take care of the scuba diving. When we are going to do scuba dive, and we are going to climb the hill, so we have to take some precautions. Okay, so this is all. This illustrations for the solubility of gases in liquids with the increasing pressure. Okay, so this is all about the solubility of gases in liquids. So students, the next one is vapor pressure of liquid solutions. Vapor pressure of liquid solution. Okay, so this vapor pressure of liquid solution. So liquid solution means liquid is the solvent and solid, liquid, gas is the solute. So here solid, liquid also there. So liquid also there and gas liquid also there. So this gas liquid solution, we just studied the vapor pressure of the liquid in the solution. We just studied how the gases are dissolved in liquid. So we will discuss with solid liquid and liquid solution. So in this students, we are going to study about the volatile solutions. We are studying only about volatile compounds or volatile solutions. Means solution may consist of either solvent or solute must be a volatile substance. Okay, whether the solute may or may not be volatile, but liquid must be volatile. Okay, volatile means it easily evaporates. So here we will study with what? liquid solution. That is vapor pressure of liquid solution. Okay, so students, this vapor pressure of liquid solution is explained by what? Raoult's law. Explained by Raoult's law. That is very important law. So here I'll write the statement first. What is the statement of Raoult's law? So in this for solution of a solution of volatile liquids, not liquid, is volatile liquids. The vapor pressure of each component is directly proportional to the in the solution is directly proportional to the mole fraction present in the solution. Mole fraction of component in solution. So this is very important definition of Raoult's law. What it is? For solution of a volatile liquids, the vapor pressure of each component in the solution is directly proportional to the mole fraction of component in the solution. So that is vapor pressure is taken as P and is directly proportional to what? Mole fraction. So this is the mathematical expression of Raoult's law. So this is P means to remove this proportionality, this is taken as P naught into X. The P is vapor pressure of component. Okay. P naught means vapor pressure of pure component and X is mole fraction. X is mole fraction. So P is directly proportional to X. P is equal to P naught into X. So P is equal to vapor pressure of a component and P naught is the vapor pressure of a pure component. So with respect to this, students, we can calculate a equation for the vapor pressure of a two different volatile liquids. So you know solution means solute is there, solvent is there. If both solute and solvent has two different volatile value, then we will get different. So let us consider components 1 and 2 with partial pressure P1 and P2 and mole fraction X1 and X2 respectively. Okay, so vapor pressure of liquid solution. I am deriving the equation. Let us consider the components 1 and 2 with a partial pressure P1 and P2 and mole fraction X1 and X2. Then apply Raoult's law. So for component 1, component 1, what happens? Raoult's law means P is directly proportional to X. To remove the proportionality, we did P naught X. So this is for first component, means this is in this plan. Okay? So for component 2, P2 is equal to P naught to X2. Okay, so now we know that total vapor pressure is equal to sum of vapor pressure of 1 and 2 components. 1 and 2 component. Okay, so here total vapor pressure means P total, that is equal to sum of individual pressure P1 and P2. Here we have values P1 and P2. So P total is equal to P1 is P1 naught X1 plus P2 naught X2. Okay, students, in this we know mole fraction X1 plus X2 is equal to 1. Here we have X2 means X1 is equal to what? 1 minus X2. So you apply here. So P total is equal to P1 naught 1 minus X2 plus P2 naught X2. Then you will get P1 naught minus P1 naught X2 plus P2 naught X2. Then you will get here minus is there, here plus is there, that is P1 naught minus X2 into P2 naught minus P1 naught. This is what? P total. Okay students, here you will came to know what? The following conclusion shows here the total vapor pressure of the solution is depends on what? Only mole fraction of the one component. It varies with only the mole fraction of the second component. Here one component in the equation we don't have 1. X1 is not there, mole fraction of one component is not there. So this complete the vapor pressure of the entire liquid it depends on what? Only the mole fraction of one. Okay, so this is the equation. With respect to this, if we draw graph means so listen, this is the graph here. Above, you can see this is mole fraction, this is partial pressure. Okay, so here x1 is equal to 1, x2 is equal to 0. Here x1 is equal to 0, x2 is equal to 1. So then what happens? You will get the graph students in this manner. This is P1, this is P2. Okay, then you will get graph like this. Okay, this is what? This is P1 naught, this is P2 naught, this one is P2, this one is P1, this is P1 plus P2. This is P total. Okay, so this is the graph that shows what? Here, listen, x1 keep on decreases, x2 keep on increases. Here 0 to 1, x2. Here x1 1 to 0. So x1 value. Then also, if x2 value increases, then the pressure increases. Here x2 value decreases, but it never shows the decreasing curve. So here this graph shows what? The entire equation are in a volatile compound. So liquid solution is there. If both are volatile, the partial pressure of the one solute is based on what? So one liquid is based on only mole fraction of the one component. Here x2 is 0 and changes to 1. Keep on increasing means pressure also increases. As I told you, mole fraction increases, pressure increases. So this curve shows the vapor pressure of the liquid solution. So students, here the P1 P2 versus mole fraction x1 x2 for a solution gives a linear plot. Okay, so here one part they meted here, right? So this part where they meet, this is what x1 and x2 both are equal. That is x1 equal to x2. The point where they meet at each other, so that point is x1 is equal to x2. Means they are at a unity. So this shows the equation for the vapor pressure of a liquid in liquid solution. Gases in solvent, gases in solution. I write. I love this and I will tell equation for gases in liquids. Vapor pressure of gases in liquid. Explained by what? Henry's law. So P is equal to KHX. Next, vapor pressure of liquids in liquids. That is explained by who? Raoult's law. Formula P is equal to P naught X. Or if you want to check the total vapor pressure of the volatile compound, that is this is the equation. I hope you understood, students. This is already we studied the gases in liquids, next liquids in liquids. The next class we will study solids in liquids. Okay, so this is all about the vapor pressure of a liquid solution, and both must be what? Volatile solution. So regarding this, we will go with some problems. We will discuss in the next class. Thank you.